Hello and welcome to this course on thermodynamics. I am Anand from the Department of Mechanical Engineering at the Indian Institute of Technology, Madras, and I am going to be offering this course over the next 12 weeks or so. Thermodynamics essentially deals with the conversion and conservation of energy in various forms, and it forms the basics or fundamentals of practically all fields in the area of thermal engineering, and also it is something which would be used in many other varied fields. So, for example, if you were to design say a chip or a cell phone or a flask or an engine or an aircraft, at some point of time somewhere you would need to use the concepts of thermodynamics, and thus we see it is something very fundamental, and it would be something which would be important to learn irrespective of what branch of engineering you are from. This course is essentially pitched at undergrad students, at first and second year undergraduate students, but nothing prevents it from being useful to students who are in any other year or course which they may be in. Some examples of the devices which we can look at from a thermodynamic perspective include these pictures which are shown here. So, over here for example, we see an internal combustion engine of the kind which is commonly used in say automobiles, two-wheelers and four-wheelers and so on. Here we see a jet engine. Here we see what is called as a turbofan engine, which is commonly used in aircraft these days. This picture here shows a hydroelectric dam where we store water and then discharge it through a turbine to get work which we convert into electricity. And here we see what would be the working cycle of a power plant, where we have a pump, a boiler, a turbine and a condenser, and we connect this turbine to a generator and produce electricity which powers most of the stuff which we see around us today. All of these devices and many more can be analyzed using the principles of thermodynamics, which we will study in this course. It is interesting to see what other people think of thermodynamics. So, here I have a quote by Arthur Eddington, who was an astronomer and physicist, and possibly is most famous for first finding out evidence in favor of Albert Einstein's theory of general relativity. So, he says the law that entropy always increases, which is the second law of thermodynamics, holds, I think, the supreme position among the laws of nature. So, it is very clear that he thinks it is one of the most important laws which are ever there, and he goes on to say that if you for example have some other theory and you find evidence in favor of it, there could be two things. One is maybe the evidence is not correct because experimentalists sometimes make mistakes, but if the evidence is in favor of your theory and your theory is at odds with say Maxwell's equations, then maybe the Maxwell's equations are wrong. But what is more interesting is this part over here. So, he says, but if your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. So, it is quite clear how at what level he places the second law of thermodynamics and thermodynamics in general by looking at this quote. It is also interesting to look at Einstein's quote on thermodynamics, because he has a preamble on theories in general, but then he points out that thermodynamics made a deep impression upon him, and he goes on to say, it is the only physical theory of universal content which I am convinced will never be overthrown within the framework of applicability of its basic concepts. So, here we have quotes from two eminent scientists who are both famous in their own right, and both of them tell you why it is important to learn thermodynamics. But what I like to think of is also a sort of humorous quote from Sommerfeld. Arnold Sommerfeld was of course one of the founding fathers of quantum mechanics. What is also interesting is he is possibly one of the scientists who had the most number of students who went on to win Nobel Prizes, and he is possibly the person who was nominated for the Nobel Prize the most number of times. I believe it is about 84 times or so. He is also an eminent scientist in his own right, one of the real great scientists whom we have had. So, he says thermodynamics is a funny subject. The first time you go through it, you do not understand it at all. That is pretty sad for us. The second time you go through it, you think you understand it except for one or two small points, So, we should possibly learn thermodynamics twice at least. The third time you go through it, you know you do not understand it, but by that time you are so used to it, it does not bother you anymore. So, I think it is quite an interesting comment. Of course, what it tries to highlight is there are a lot of fine points in thermodynamics, but the reason I think we have this course is that it gives us an opportunity, it gives you an opportunity to look at the lectures as many times as you want. You can go through the textbooks as many times as you want and relook at the lectures, and hopefully by the end of this course you will have a good understanding of this subject. So, that is one of the reasons we are recording this. And in this course what we are going to do is to look at the fundamentals of thermodynamics, define what is work, look at temperature and look at the zeroth law of thermodynamics in that context. We will define heat, we look at the first law, which is the law of conservation of energy. We look at various substances, what we call as ideal gas and their mixtures, two-phase systems. We will go on to the first law for what are called flow processes. We will look at the second law, we will look at what is called as entropy, and in that context we will look at the third law of thermodynamics as well, and then we will go on to applications which are thermodynamic cycles. If you do go through this course and follow all the lectures and do all the assignments, what we hope is that at the end of the course you should be able to analyze thermodynamic processes and cycles involving heat and work. You should be able to evaluate the performance of these thermodynamic systems and such as, for example, a steam power plant or a refrigerator or something like that. And more importantly, what we hope is that you will be able to identify hypothetical scenarios which violate the laws of thermodynamics, because as has been pointed out by the other people, those scenarios cannot be true. So, this is something which we hope that you will be able to do at the end of the course.